Hello everyone, welcome back to my channel Technical Talks ka Pitara. Today we are going to talk how MicroStrategy is going to calculate logical table size. So I hope you know what is logical table size. If you do not know, I'm just going to briefly explain that. So basically each and every table that is there in MicroStrategy, those logical tables, there will be some weightage assigned to that based on the number of attributes as well as at which level they exist. So either we as a MicroStrategy architect going to assign a particular logical table size manually, or otherwise by default MicroStrategy itself is going to assign a logical table size to the each and every individual logical tables. So basically any table which has higher level of attributes, that means which is there in up into the hierarchy, is going to have the smaller in size. I'm going to prove that very soon. So let's try to figure out how MicroStrategy assigns the logical table size, but at the same time I would like to tell two things. If you could recall, when we update the schema, that time MicroStrategy recalculates those logical table size. Correct? I'm sure you must have seen the option. And in case there is some scenario where you want, say for example, there are two tables with the same logical table size. So uh, if you want explicitly another table to take precedence over the first table, then what you can do is you can reduce the logical table size of that particular table. So the benefit of this logical table size or the use case is that MicroStrategy automatically gives the logical table size to the table, and in case you want some specific table to be used, you can change the logical table size for that particular table. So now let's understand how MicroStrategy calculates this logical table size. So for this, let's consider this example where we have our first hierarchy. Here we have lookup table A, lookup table B, lookup table C, lookup table D. So four lookup tables are there in my hierarchy 1, and there is another hierarchy in which lookup table E, lookup table F, lookup table G, lookup table H. Again, four tables are there, and there are this list of fact tables F1, F2 and F3. So this logical table size is being calculated into three steps. The first step is to find out the number of levels in each hierarchy. So you can see there are two hierarchy. This is the first hierarchy. The level is going to be, this is first level, this is going to be the second level, and this is going to be the third level. So hierarchy one is going to have three levels, and in case of hierarchy 2, it's 1, 2, 3, 4. So hierarchy 2 is going to have 4 levels. So now we have understood how many levels are there in each hierarchy. The next thing is to identify the individual weight for each attribute. Okay, so for that, the formula to calculate individual weight for attribute is to take the level in the hierarchy divided by the total numbers of levels in the hierarchy. So let's consider this example of attribute A. So attribute A is coming from, in this case, it's a level 1, correct? It's the first level. When I talk about the first hierarchy, just consider about this part, okay? The hierarchy 1. So attribute 1 is coming from the first level, and total number of levels in this case hierarchy 1 was 3, correct? So 1 divided by 3 multiplied by 100 is going to be, multiplied by 10 is going to give me 3.33. So the formula is level divided by the total number of levels multiplied by 10. So in this case we got 3.33 for this attribute A. If I check for attribute B, in case of this hierarchy only, then you see that level 1, level 2. So this is level 2. So 2 divided by 3 multiplied by 10, So this is going to be 6.66. Similarly for C, one catch here is, you see that C is not at the second level, it's at the first level, it's at the top level. So it's going to be calculated as 1 divided by 3 multiplied by 10, which is again going to come as 3.33. And for D, the level is going to be the 3. So 3 divided by 3 multiplied by 10 means value is going to be 10. Okay. Similarly, if I talk about the hierarchy 2, if I calculate this weightage of this attribute E, it's going to be the first level. So 1 divided by 4 multiplied by 10. Similarly, 2 divided by 4 multiplied by 10, 3 divided by 4 multiplied by 10, 4 divided by 4 multiplied by 10 for H. So this is how we have got for E, F, G, H. And always we should pick up the attribute at the topmost level. So it doesn't mean that if A attribute is here, I need to pick it from here, because we are looking for the lowest level, correct? So that's why we should take from the top one. So in this case, you say that this is what the weighted we got: 3.33, 6.66, 3.33, and so on. So second step is complete. Now let's see the third step, where we are going to see each and every table, whether it's a lookup table or the fact table, and all the attributes. So we are going to take the sum of all the weights of those attributes and going out to round it off. So for lookup table A, you remember, if you go back, lookup table A, only one attribute. So rounding of 3.33 is going to give you 3. Similarly, for lookup table B, you can see that there are two attributes, A and B. So in this case, rounding of 3.33 plus 6.66, which is nothing but 9.99, it's going to come as 10. So that's how, if you see here, each and every single table, whether it's a lookup table or fact table, you get to know what is the logical table size for each table. Okay. So now once we get to know how MicroStrategy has calculated this table, the logical table size for each and every table, now consider that a scenario that where you are running a report. So what is going to happen in the backend? The MicroStrategy SQL engine is going to determine which attribute to be taken from which table. How it is going to do that? Using this logical table size. So whichever table has least logical table size, MicroStrategy is going to pick that. So let's consider that I have a report where I want to show my attribute A. So if I want to show my attribute A, this can be picked from lookup table A, it can be picked from lookup table B, it can be picked from the lookup table D, it can also be picked from the fact table F1, it can also be picked from the fact table F3. So if you see here the logical table size for this case where I need to get the attribute A, the least logical table size is going to be 3, because 3 is lesser than 10, 3 is lesser than 23, 3 is lesser than 55, and definitely 3 is lesser than 8. So in that case, this A attribute MicroStrategy is going to pick from the lookup table A. Now consider the scenario where there are two attributes and those are coming from the two different tables and the logical table size are same. In that case, MicroStrategy is going to take the table which is closest to the memory, like first table into the memory. So you know that into the memory all the tables are loaded, right? So whichever is like closer to the memory, it's going to pick that table. Okay, in this case I do not have an example, but this is how it's going to work. So consider there is a scenario, though it doesn't make sense here, but consider that this attribute A and C, okay, both in this case logical table size 3, but here it's attribute A, here it's attribute C. Consider both are same attribute and two different lookup size, correct? So whichever table is coming first, consider that lookup table A is there first into the memory, so this one will be picked. Or if you want to explicitly take this table lookup table C, what you can do is you can reduce this logical table size from 3 to say 2 or 1. So in that case, if logical table size is lesser, that's going to be picked. So this is the significance, how MicroStrategy works, how the logical table size are defined, or how you can manipulate or change the logical table size. I hope this makes things clearer. So I thank you all for watching this video, and if you like it, please do like, share and subscribe to my channel. Have a good day. Bye.